Welcome to our comprehensive Java tutorial series. Whether you're completely new to programming or looking to enhance your existing skills, this series is designed to take you from foundational concepts of Java all the way to advanced topics. In today's fast-paced tech environment, mastering Java is essential, as it is one of the most widely used programming languages in the world. Throughout the series, we'll cover everything from variables and control structures to object-oriented programming and design patterns. By the end of our journey, you'll not only understand Java's syntax and functionalities, but also gain the practical skills required to build robust applications. So, let's dive into the fascinating world of Java together. Features of Java. Java is one of the most popular programming languages. It is object-oriented programming language. It is platform-independent. It has rich APIs and community support, as well as it is portable and secure. So, what is object-oriented programming? Object-oriented programming, OOP, is a methodology or paradigm to design a program using classes and objects. So you could think of it as like a program where everything is represented as objects in class. So let's look at this example to make it easier to understand. Think of a person. A person can be represented as a program. Now, imagine we have a class called human. This class serves as a blueprint that defines the common properties and behaviors of humans. For example, humans have properties like nationality, ID, phone number, height, and occupation. These are like the attributes of the function. Humans also perform activities like eating, sleeping, drinking, working, and running. In programming, these activities are called methods. So a class like human is a blueprint that describes the structure, which are properties, and actions, which are methods of an object, in this case, a person. So what is an object? An object is an instance of class. While the class is a blueprint, the object is the actual thing based on the blueprint. For example, let's take the human class we just talked about. If we create an object called John, we can assign him specific values for the properties defined in the class. Let's say his name is John, let's say his nationality is American, let's say his ID number is 12345, his phone number is XYZ, his height is 5 feet 9 inches, his occupation is software engineering. John can also perform the methods defined in the class, like eating, sleeping, working, or running. So John is an object of the human class. He has all the properties and behaviors described in the blueprint, but with its own unique values. Each object is like a real-world representation of the class. So let's take another example. Imagine you're designing a house in a neighborhood. First, you need a blueprint that defines what a house should look like and what features it should have. This blueprint does not represent any specific house. It's just a design. In programming, this blueprint is called a class. For example, let's create a class called house. It has properties like color, number of rooms, has garage. So it also has methods or actions like lock doors, turn on lights, open garage. Now, when we build an actual house using this blueprint, that's an object. Each house objects can have its own unique values for the properties. For example, house 1 has color blue, number of rooms 3, has garage true. House 2, color red, number of rooms 5, has garage false. Each house is an object of the house class. It follows a structure defined in the class but has its own specific details. So in OOP, the class is like the blueprint and the object are the actual instances created from it. This makes it easy to create and manage multiple objects with similar properties and behavior. Java was developed in the early 1990s by James Gosselin and his team at the Sun Microsystems. Before Java, languages like C were platform dependent, meaning you had to rewrite code for each operating system or hardware. This was time consuming and inefficient. Gosselin wanted to solve this problem by creating a language that could run on any platform without modification. This led to the write once, run everywhere concept. Here's how it works. Java code written in the .java file is compiled into a bytecode, a .class file, which is a platform-independent code. Each operating system has its own Java virtual machine, JVM. The JVM takes the bytecode and converts it into machine code that the specific operating system can understand and execute. This means programmers don't have to worry about writing different code for different platforms, so they can write it once and run it everywhere. And this is how the Java language is considered platform independent. So, what is Java Development Kit? The Java Development Kit is the complete package needed for Java development. It contains everything a developer needs to write, compile, and run Java programs. So Java consists of some main components, which is development tools. So these are the tools like the Java compiler and the Java debugger. They allow you to write and convert Java code into a format that the computer can understand. And there's also the JRE, which is Java Runtime Environment. The JRE is a subset of the JDK, and it is what allows your compiled Java program to run. The JRE itself has two main components, which is the Java virtual machine and other libraries and other files. So the JVM is the engine that runs Java programs. It converts the Java bytecode into machine code that your computer can execute. It also handles other features like platform independence and garbage collection. Libraries and other files. These includes pre-written Java libraries like java.util and java.io that provides functionalities you can use in your program. So to summarize, the JDK is a complete toolkit. It consists of development tools to create programs and the Java runtime to run those programs, and inside the JRE is the JVM and libraries that makes everything work.